Welcome back to All This Math. This is Professor Parker. Please make sure you're subscribed to the All This Math YouTube channel. If you learned something on this video, please remember to like the video, drop a comment down below or something, and also share the video with some other people. All right. And today's video is brought to you by Mathematics. What are we doing today? What are we doing? What we're doing today is we're going to solve this equation by graphing it. All right. We're going to solve this equation. 9x minus 7 is equal to negative 6x plus 8 by graphing it. Now we're going to use a method that some people like to call the intersection method. I like to call it the divide and conquer method. All right, divide and conquer, a very important political concept, right? That we all should understand, right? But I'm not going to get too deep into that right now. But definitely it's something for you to look into on your own if you're not familiar with that divide and conquer. Why do I call it divide and conquer? Because what you do basically is you take this equation, right? You take each expression on each side of the equal sign and you create an equation. You basically divide this equation up into two separate equations or two separate expressions. And then you take each of those expressions and you create an equation out of each of those expressions. All right. So what you do is like this. It's kind of like taking a system of equations, kind of like you're creating a system of equations. Whereas a lot of times you might be given a system of equations and then you have to create a single equation, right? In this method, we're doing the opposite. We're going in the reverse direction. All right. So what we're about to do is I'm going to create two equations. All right. And I'm going to set each of them equal to y. So we're going to have y equals 9x minus 7. And then we're going to have y equals negative 6x plus 8. All right, so I'm going to write those down. I'm going to have y equals 9x minus 7. And then I'm going to write it down here. Y equals negative 6x plus 8. So these are our two equations, right? Now also think about the transitive property. If A equals B, then B equals C, and B equals C, that means that A equals C. So if both of these expressions are equal to Y, then that means both of these expressions are equal to each other, right? Because they both equal to the same thing. So that means they both got to be equal to each other, right? So isn't that what happened in the first place? These expressions were equal to each other. So all we did was rewrite them, each expression equal to the same variable. That's all we're doing. All right. And then it's called the intersection method because we're going to graph each of these equations, this one up here and this one down here, and we're going to see where they intersect at on this graph. And wherever they intersect at, the x coordinate of that point is the solution. Now, of course, we could use traditional algebraic techniques and solve for x. We could do that, but that's not what we're asked to do. We're asked to solve by graphing. So I know somebody might get upset and say, well, why we got to do all that? Why can't we just solve it using regular algebra? Well, because they ain't asked you to do all that, right? That's not what the instructions say. All right. And it's good to know how to do things in many different ways. So don't just get upset because you're being challenged to use a different method that you're not as familiar with. Just learn the method and you're going to be better for it because now you got multiple methods of solving problems, right? Why would you want to limit yourself and have less methods of solving problems? You want as many as possible. All right, so let's get into it. So let's start with this one. All right, now fortunate for us, this is already in slope-intercept form, right? Y equals mx plus b, right? Or plus negative 7, right? B could be negative 7. So what we want to do is we want to plot the y-intercept first. My y-intercept is negative 7, not 9, not x, not y, but it's negative 7, all right? So a line has like millions and millions and billions and billions of y values on it, right? Because it's got millions and millions and billions of points on it, and every point has a y value, right? But the most important, one of the, or probably the most important y value is the y-intercept. So what we're gonna do is we're gonna find negative 7 on the y-axis, not the x-axis, not the x-axis. A lot of people like to do that. If it's the y-intercept, it's on the y-axis. It's on the y-axis. It's on the y-axis. That's why it's called the y-intercept. Where does this line intercept the y-axis, or where does, you know what I'm saying, this line get intercepted by the y-axis? Imagine the y-axis is the defensive back. The line is the football that's being passed, right? And it gets intercepted at a certain point on the y-axis. Think of it that way. So I'm gonna find negative 7. So I go here. This is 0. -1, -2, -3, -4, -5, -6, -7. I draw my point right there. That's -7. What's my slope? My slope is +9. Slope is +9. So because my slope is +9, I could rewrite that as a fraction. Not m equals 9/1. Convert 9 to a fraction. The top number or the numerator indicates vertical movement. Because it's positive, we're going up 9 spaces. The bottom number or the denominator indicates horizontal movement. Because it's positive, we're moving to the right 1 space. So I'm going to go up. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1 space. That's my second point. Now, you only need a minimum of 2 points to draw a line. Some teachers recommend or enforce that you need to draw 3 points and then draw the line. I ain't one of them. So I'm cool with just 2 points. So let's draw a 2 point. Let's draw a line through the 2 points. I got my ruler. And okay, here we go. So that's our line, right? That's our line for y equals 9x minus 7. Now we're going to do the same thing with y equals -6x plus 8. And then we're going to see where the lines intersect each other. Wherever they intersect each other, the x value of that point is the solution to the equation. All right, so my y-intercept in this equation is +8. So I go up here on the y-axis, not the x-axis. I go 1, 2, 3, 4, 5, 6, 7, 8. Draw my y-intercept. My point's right there. Then my slope is -6. My slope is -6. So if I represent that as a fraction, that's m is equal to -6/1. So the top number tells me my vertical movement. Because it's negative, that means I'm going down 6 spaces. The bottom number tells me my horizontal movement. Because that's positive, that means I'm sliding to the right. So from the y-intercept, I'm going down 6 spaces and to the right 1 space. Down 6 spaces and to the right 1 space. I'm just following directions. That's all I'm doing. Most of math, whether it's algebra, geometry, pre-calculus, whatever, as long as you know the rules, all you got to do is follow the rules. Just follow the rules. You're going to be all right. So now I'm going down. I'm going 1, 2, 3, 4, 5, 6, and over 1. And look at that. Look at that. It overlaps. It overlaps one of those points. All right. So now I'm going to draw my line, even though I only have to, but I'm going to draw my line because I already see what the answer is. I'm going to draw the line anyway. Right? So I do that. Let me go down with it. Draw a line. Put the arrowheads on the ends. Boom, that's that. Now, where did it intersect at? Intersect around here at, I believe, +1, +2. Now, we only care about the x value. All right? The x value, right? X value is 1. So this is our solution. X equals 1. X equals 1. The x value of the coordinate of the x value of the point, which is the intersection point. The x value of the intersection point is our answer. And if we want to check our work, 9 times 1 is 9, minus 7 is 2. -6 times 1 is -6, plus 8 is also 2. 2 is equal to 2. This +1 gives us a true statement. Therefore, you know this is the right answer. All right? And right there, that is the intersection method. The intersection method, or what I like to call divide and conquer. Divide and conquer. You divide this equation up into 2 separate expressions, and then you make each expression equal to y, and then you got your 2 equations, and you just take it from there. All right. So, just another method for solving linear equations, right? And we should know as many methods as possible. All right. So go out, practice, find some problems like this, practice them, master them, and I'll check y'all out on the next video. I'm out.